August 1944. A crippled American bomber limps towards Soviet territory. Its crew doesn't know it, but they are about to hand Stalin the future of Soviet air power. Within 3 years, an identical aircraft would roll off a Soviet assembly line. Not similar. Not inspired by. Identical, down to a patched bullet hole. This is the story of the most advanced bomber of the Second World War, and how it became the aircraft that armed the Soviet Union for the atomic age. In 1944, the B-29 was the most complex machine ever put into mass production. Pressurized cabins. Remote-controlled guns. A bombing computer more advanced than anything in the sky. It carried the bombs that ended the war. But its greatest legacy wasn't the missions it flew, it was the aircraft it accidentally gave away. The B-29s would land in Soviet Siberia during the war. Stalin would return none of them. Instead, he ordered his engineers to rebuild America's masterpiece, screw by screw. To understand why the B-29 mattered so much, you have to understand what came before it. In 1938, American bombers still flew unpressurized, at the mercy of the weather. The U.S. Army Air Corps needed something radically different, a bomber that could fly higher, farther, and faster than anything the enemy could intercept. In 1940, Boeing answered with a design so ambitious it terrified even its own engineers, a pressurized, high-altitude superbomber called the Model 345. Pearl Harbor changed everything. The United States needed a bomber capable of striking Japan from thousands of miles away. The B-29 program became the most expensive weapons project of the war, more costly than the atomic bomb itself. The first XB-29 prototype flew in September 1942. It was a leap into the unknown for engines never before flown at this size, pushed to their absolute limits. Those engines, the Wright UL-3350, were the program's greatest weakness. Powerful, but prone to catching fire in mid-flight. On February 18, 1943, a prototype caught fire and crashed into a Seattle meat-packing plant, killing test pilot Eddie Allen and his entire crew. Despite the tragedy, the program pressed forward. Too much was at stake to stop now. General Henry Hap Arnold pushed the B-29 into production before testing was even complete. By 1944, production lines in Kansas, Georgia, and Nebraska were turning out superfortresses by the hundreds, an industrial effort unlike anything the world had seen. What made the B-29 revolutionary wasn't just its size, it was pressurization. For the first time, a bomber crew could fly at 30,000 feet without oxygen masks. A pressurized tunnel connected the forward and rear crew compartments, crawling above the bomb bay, an engineering solution no one had attempted at this scale. Instead of gunners manually aiming turrets, the B-29 used a first-of-its-kind remote fire control system, letting one gunner control multiple turrets through an analog computer. The Norden bomb sight, paired with an analog targeting computer, gave the B-29 bombing accuracy previously thought impossible from 6 miles up. With a wingspan of 141 feet and a range of over 3,000 miles, the B-29 could strike targets no other bomber on Earth could reach. Before combat, the B-29 had to survive its own testing program, a brutal process of trial, failure, and redesign. Engine fires remained a constant danger. Crews nicknamed the UL-3350 the Cyclone of Death, a risk every bomber crew accepted before ever facing the enemy. Test pilots pushed the aircraft to its structural limits, high-altitude stalls, emergency descents, single-engine landings, mapping the edges of what the superfortress could survive. By early 1944, the Battle of Kansas, a frantic, round-the-clock effort, finally readied the first combat-capable B-29s for deployment to the China-Burma-India theater. The B-29's combat debut came on June 5, 1944, a raid on Bangkok, launched from bases in India. It was only the beginning. Weeks later, B-29 struck the Japanese home islands for the first time since the Doolittle raid, a raid on the Yawata Steel Works, launched from China. But the real transformation came in late 1944, when American forces captured the Mariana Islands, giving the B-29 bases within direct striking distance of Tokyo. General Curtis LeMay took command and changed everything, stripping the bombers of defensive guns, loading them with incendiaries, and sending them low, at night. On the night of March 9, 1945, over 300 B-29s firebombed Tokyo. It became the single most destructive bombing raid in human history. 5 months later, 2 specially modified B-29s, Enola Gay and Boxcar, carried the weapons that would end the war entirely. On August 6, 1945, Enola Gay dropped the atomic bomb on Hiroshima. 3 days later, Bockscar struck Nagasaki. Within a week, Japan surrendered. The B-29 didn't just win battles, it redefined what a bomber could be. Every strategic bomber built afterward owed something to its design, but its most unexpected legacy began years earlier, in the skies over Soviet Siberia, with four-crippled bombers that never came home. Under the Soviet-Japanese Neutrality Pact, the USSR was obligated to intern any American aircraft that landed on its soil. It never intended to give them back. Stalin gave a direct order: reverse engineer the aircraft exactly. Not a similar bomber. An identical one, down to the rivet pattern. The task fell to Andrei Tupolev, the Soviet Union's most respected aircraft designer, who was ordered to copy, not design, a bomber for the first time in his career. One of the interned B-29s was completely disassembled, part by part, and measured down to the thousandth of an inch. Soviet engineers faced an impossible constraint: American measurements were in inches, but Soviet industry worked entirely in metric. Every part had to be recalculated without changing a single dimension. They even copied a patched bullet hole in the fuselage skin, unsure whether it was a structural feature or battle damage. They replicated it anyway. Within 3 years, the impossible was finished. The Tupolev Tu-4, externally identical to the B-29, rolled out for its first flight in May 1947. On August 3, 1947, 3 Tu-4 bombers flew over Moscow's Tushino airshow. Western observers were stunned and alarmed. The Soviet Union now possessed a bomber capable of reaching the continental United States with an atomic weapon, built entirely from a copy of America's own aircraft. The Tu-4 became the backbone of Soviet strategic aviation through the early 1950s, and directly inspired the transport and passenger aircraft that followed, and even the Tu-95 bomber that still flies today. The B-29 Superfortress ended a world war. But almost by accident, it also armed the Soviet Union with strategic bombing capability years ahead of schedule. No aircraft in history had ever been reverse-engineered this precisely, this quickly, or with this much consequence for the balance of global power. The B-29 proved that engineering brilliance can outrun its creator's control. Once built, a masterpiece belongs to whoever can copy it. Today, only a handful of B-29s remain airworthy. Fewer Tu-4s survive at all. But their story reshaped the first decade of the Cold War. 2 nations. 1 design. A single act of wartime desperation that changed the shape of global air power for a generation. The Superfortress was built to end a war. It ended up starting an arms race in